If we have already designed our abstract data type stack, we know those operations stack has. Now it is time to check several applications where we can use stack abstract data type. People are often doing blind typing, but we make mistake. For example, we use backspace to remove previous mistake character. And for this example, it will generate the following outputs: A, B, C, D, E, F, G. Each backspace erases the previous character entered. We can only delete one character at a time. We cannot delete from any other position. We cannot delete if line is empty. We need to be able to retrieve the most recently added item without removing it. Those are characteristics of stack. We could use abstract data type stack to implement line editor method. This is a pseudocode for line editor. Suppose we have the string which includes all the characters typed and also backspace. Since we don't know how many characters entered, so we need to use a while loop. While not end of line, and then we just read in one character from left to the right. And then we check if that character is backspace or not. If it is not backspace, we just add to the stack. Otherwise, we just remove the most recent added item from the stack. You can see we need a set of operations of stack abstract data type. For example, we need to determine if the line is empty or not. We need to add a character, push. We need to remove the most recently added character, pop. We need to check the most recent add item, retrieve operation of stack. Therefore, abstract data type stack can be used to perform the reading correction of the line editor. This is the pseudocode in more detail. Of course, first we need to create the stack, then process the string from left to the right, one character at a time. If new character is not end of line, check. If new character is not backspace, we just push the character onto stack. Otherwise, if stack is not empty, and then we have to pop the character from the stack. And then we keep reading the new character from the line until we reach the end of line, and then all the characters are on the stack. Here you can see we use stack constructor, push, pop is empty methods. The second example we are going to learn is to use stack to check the brackets are balanced or not. We assume all brackets are of same type, or parentheses, or square brackets, or curly brackets. Do you have any idea to evaluate? Can we simply count the number of open brackets and closing brackets? If they are not same, certainly the brackets are not balanced. Even the numbers are the same, we cannot assume the brackets are balanced because the open brackets and closing brackets are made not in the same order. So we could use stack to implement a method which can evaluate the brackets are balanced or not. We can keep track for unmatched open brackets by pushing all the open brackets onto a stack. And closing bracket is encountered, we just pop one unmatched open bracket from the stack. They are matching. Keep going and then stop when the three cases happen. When the string and the stack are both empty, that means the brackets are balanced. If stack is empty but string still contains closing bracket, means that they are not balanced. If string is empty but stack still contains unmatched open brackets, that means we have more open brackets. That is another failure case. Here is the shortcode for balanced brackets. We need to create a stack initially empty. We also need to define a variable balance so far. At a certain point of process, the brackets are not balanced, and then we don't need to go further. We start at position 0 of the string from left to the right. Process each character unless we reach end of the string or brackets are not balanced. That's why we have two conditions in the while loop. We take one character at a time. If the character is open bracket, we push onto stack. If the character is closing bracket, we try to pop one from stack to match the closing bracket. Otherwise, we just set balance so far equal to false. For any other characters, we just ignore. We keep loop until balance so far equal false. We get out of while loop, or we reach end of the string. Outside while loop, we just simply check the balance so far variable is true or false. If balance so far variable is true and stack is empty, certainly we know that the brackets are balanced. Otherwise, the brackets are not balanced. Again, here we use four operations of abstract data type stack. Constructor used to create stack. Push, pop is empty. If the string contains different types of brackets, how can we modify previous algorithm to check the brackets are balanced or not? We can simply scan expression from left to the right. We do the same each time a left bracket is encountered, push it onto stack. When a right bracket is encountered, just compare with the top item on the stack. If they are matching, we just simply pop from a stack. If no, means that brackets are not balanced. It may be the case the stack is empty, we have nothing to pop off to match the closing bracket, and then the brackets are not balanced. If there are items left on the stack after the string or expression has been scanned, and then the brackets are not balanced again. You can see the general idea is the same as previous example. We need to scan the string from left to the right. We just push left brackets onto stack, and if right brackets, and then we just simply compare with the top item on the stack to find a matching one.